We are the Cumbia team. We are a multidisciplinary team with members from all over the world that took a challenge for customer service automation. One of our potential customers is a Colombian bank. They have 1,600 people on their customer service department. They are little trained and they have a problem of mistaken assignation of customer requests. When a customer goes to the office and says they have a problem, then this person has to write the thing down and classify it. Okay, is this a problem for this department? Is this a problem for this other department? Uh, the ticket often gets misclassified, and so the bank has a lot of cost. So the idea here was to provide the bank with a tool that would help their customer agents better classify or better qualify those tickets.
So the solution that we figure out consists in implementing a natural language processing tool driven by AI technology, which allows for better assistance of the predictive actions as soon as the agent begins to take the request from the customer. The first solution we try consists in a classic classifier model, which we train from an open source dataset from Kaggle. Okay. The second solution consists in a pre-trained large language model, and the third solution consists in a fine-tuned large language model using specific examples for tuning our use cases.
For the architecture, we have three basic layers. In the front end, we are using bubble.io, which is a low-code platform where the idea is that anywhere could do a POC at least for any application. So second layer is a backend using GCP Cloud Run. This is like our Python backend using Docker, and it is auto-scalable backend application, basically. And in the end, we are communicating with Palm, which is the Google's large language model approach. And we are basically communicating the request from the front end to the backend and finally into Palm 2. And this is the response, the classified response that we get from this AI Palm 2 goes back to the Bubble front end. As we said before, we are using three different approaches, and the dataset comes from Kaggle, and this dataset was in English. So one middle step we had to do was to translate this dataset into Spanish, and then we uploaded it into GCP Vertex AI platform. This is an example of our dataset. It is basically the text with the complaint and the label as what department should take this complaint, basically. Can go on. Okay, so for the billing cost of the classic model, we the kind of the issue we have is that it takes a long time for training. This was 9 hours and 51 minutes, and they are billing for a training hour. It is $3.3 per hour. So our total costs for this model was $33, basically. The large language model were easy to train, easier because they were pre-trained. This one, the classic model, you have to provide a full-fledged data set with your own data and train for many hours.
Yes, and talking about Bubble, well, we pick Bubble because it's not too costly and it's easy to use because it requires like 2 or 3 hours of training, and basically the training is like watching some videos to understand how Bubble works. And if you see, you can pay like $29 a month, or if you want like more apps, more app editors, like 2 or 5. Well, this is the amount you have to pay monthly, but it's not very costly, so that's why we picked that one.
We figured that this type of solution is feasible. It can provide customer service, and the training of the model was done really fast. Now, that means that the type of solution is really versatile, which means you can use your own data, you can train the model, and it can work for your exact use case. Using GCP allowed us to have high availability, from the get-go without incurring into any extra development. And since all of the setup is pay per usage, it means that we maintain a low minimum cost. Regarding code, we did this whole thing in just one Python file that's about like 210 lines long, which means that this really generates value and allows to go to market fast with a solution for a specific AI problem. This can be used for customer services or for anything actually that has a team that needs to sort things, to classify things.
Kind of history. As we say, we are using the model to translate to Spanish, so I'm going to write in Spanish. So um, so I'm writing, I lost my credit card in the park. So let's send. And we are getting, this is a credit card problem, or this is a credit card area that have to be the one who solve this question we are asking. Let's going to make a test. I'm writing, for example, I know I'm writing my name to see what happens. And if I write my name, it's getting me undefined. It means I have to write up a problem I have with some of the areas of the bank, because the model is trained to identify that kind of words and phrases that we are writing and we are asking. So getting back, we continue with the load test.
Yep. The QA part as well, as you know, the QA is the most important thing as well for the quality. So just you saw the demo where we did take care all the positive and negative things as well, that as David shows. So yep, and we did a load test as well for the queries. So in the load test, we did for a 50 users for the 5 seconds, where we are like giving a 10 users in 1 second, and with here is the report. So it's a very good report, and there are no errors as well. So yep, 90 percentile, 95, and the 99 percentile, which is a very good response. And also can you go back to the next slide? Yep. And also if you see the whole the 50 responses as well, all have good status and the good response time as well. So the next one. Yep. And if you see the graphs as well, the average and median, everything is the up to the mark, and we have a very good throughput as well. So yep.
Did here was two group, like different criterias that we found in the different three models, and we assigned to each model to each criteria in order to get a more clear view of the difference and discrepancies between the three of them. For the training time, the classic model took 9 hours 35 minutes. For the long large, it does not apply. And for the fine-tune large model was 1 hour 56 minutes. For the training sites, for the classic, there is more than 100,000 records, as you can see there. For the long large, it does not apply, and for the fine tune, we took only 1,200 records. The response time for the classic is low, for the large is high, and for the fine tune is also high. For the multi-language support, for the classic is it does has the multi-language support. For the large, it doesn't count with it, and for the fine tune, it doesn't count with it either. And the accuracy, for the classic model, it depends on the data set. For the large model, it depends on the subject matter. And for the fine tune long large, depends on the tuning data that we put in.
We learned that like in an afternoon you can start being kind of productive in Bubble, but it's you need to know a little bit more of code than we would like. Now, regarding large models, we were able to go from from idea to deployment in 1 day. So you can deploy these things really fast thanks to cloud providers. However, classic models, though they're a pain to train because it costs money, at the end of the day, their response times are good and they scale very well regarding usage. So they're very good. And all of this, us being able to use three different models in the space of a week tells us that AI is now a commodity and can be used on demand, much like computing, much like databases. So this is a thing to keep in mind. Now, the third solution we found, the fine-tuned large model, is a very good middle ground because you can adapt an existing model with not so much training problem, and it makes it fit your specific data. So to us, this gives us an idea that classification problems can be solved to customers, and that these types of solutions, Nisum is ready to adapt them and to use them on whichever customers we want. Thanks, everybody.